Good day to everyone who's watching. In our lesson today, we are going to talk about surds. A surd is a root which cannot be expressed as a fraction. We have a part A there and then the part B. Some of the examples. These ones here in the part A, all of them they are surds. When you try to get the root of 2, this is what comes to the display of your calculator. And also when you try to get the roots of these other numbers here. But when you try to get the root of 4, the square root of 4 is 2, square root of 16, there is 4, cube root of 8 is a 2 there. So numbers down here, they don't qualify to be surds, but these ones here in part A, all of them, they are surds. Now, even here, when we get the cube root of 16, it is going to give you an answer of that form. Even this one here qualifies to be a surd. Square root of 8 also qualifies to be a surd, because when you place it on the calculator, it's going to give you a number of that form, of which you cannot make a fraction or convert into a fraction. We have there some laws that we are going to be following as we are dealing with the surds. First, if I have root of A times root of B, this one here can be the root of A times B, that is, the root is the same here, then we are allowed to multiply those values there. This applies only to multiplication. If I have root of A plus root of B, I know people are going to say some things here which are wrong, but this one here just remains the way it is there. It only applies to multiplication. And this one here we also saw in indices. The other A is raised to a half times the B there raised to a half. So since the power is the same, or the order is the same, that's going to be A times B, and then power a half there. And then this power half is the one that we call the square root. So that first one comes from the idea of indices. Then here, if I have root of A times root of A, we say it's going to be A times A under the square root. The A rows of indices, A times A is A squared, and then the square ends up cancelling with the square root to have A there. So that second one, we shall be looking at it. Maybe an example, 3, root of 3 times root of 3. This one here gives us root of 3 times 3, which is root of 9. And root of 9, you get a 3. So whenever you have root of a number times root of the same number, we just get that particular number without the square root there. Roman 3 also is coming from the laws of indices. The root, we say it's going to be power half, that is A all over B, power a half. We said when you remove the brackets, the power must distribute on each base there in the numerator and in the denominator. So these ones here, they are the ones that we call the square roots. Root of A all over root of B. And this one here is the one that we have as root of A divided by B there. So it is also coming from the indices. So if I have root of 2 divided by 3, someone can say that this one here, it is the same as root of 2 divided by root of 3 right there. Roman 4, we have the addition and subtraction of surds there. If I have 2 root 3, then plus 4 root of 3, that this one here, we keep the root there and then we add the coefficients of that root of 3. So that is 2 plus 4 into the root of 3 there. And then when I add here, I'll be having 6 root of 3. We are going to start with simplifying the surds there. That is reducing them into the simplest form. For example, if I have my root of 8 there, step 1, I'm going to identify any square number under that 8 there. So 8 is the same as 4 times 2. This 4 is a square number. Then I'm going to substitute it there. So that is going to be 4 times 2 instead of now writing the 8. Then I use one of the laws of surds, that is, I can get this root of 4 times root of 2. Then this one here becomes a 2, and then times the square root of 2 there. So this is what we are going to do for all those parts there. Part A, root of 24. So this 24 here is the same as 4 times 6. So here I'm going to substitute 4 times 6. Then I can write them using the first rule there of surds that we had. So this is going to be root of 4 times root of 6 there. Then finally, this one becomes 2 times root of 6 there. Part B, root of 18. So the 18 there can be written as 2 times 9. Some other person can write it as 3 times 6. Now, when you write 3 times 6 and you substitute here, root of 3 times 6, that's going to be root of 3 times root of 6. So here, there are other numbers that are embedded there, which we can easily simplify if we use 2 times 9 there. So I'm going to opt for this 2 times 9 because 9 is a square number. So this one is the same as root of 9 times root of 2. Root of 9 is 3, root 2 there. So that is the simplest form of root of 18 there. But C, root of 72, we can have 72 as 36 times a 2 there. And that is what I'm going to substitute here. This is 36 times 2. Then root of 36, then times root of 2. So root of 36 is 6, then root of 2 there. Another person can simplify slowly by slowly. That is 72 is the same as 8 times 9 there. So we can substitute this. Root of 72 is equal to root of 8 times a 9 there. So this is going to be root of 8 times root of 9. Root of 9 is a 3. So this one is going to be 3 times root of 8. And this 8 here also has 4 times 2. So this is going to be 3 root of 4 times 2. So this is going to be 3 times root of 4, then times root of 2. Root of 4 is a 2. 3 times 2 times root of 2. Then 3 times 2 is the one we got here as 6. Then times the root of 2. Part D, root of 108 or 108. So the 108 is the same as 36 times 3. Then I have root of 36 times root of 3. Then root of 36 is 6, root of 3 right there. You need to be able to identify a square number, of which when you write them as disjoint square roots, you can get the square root of that square number. Example 2. Express each of the following as a square root of a single number. Now we have been removing part of the square root number and then we remove it from those ones there. Now we have been given those ones to take them back as a single square root. We have been having such a number and then we have been told to simplify. We said you write this number as a product of two numbers, of which one is a square number. Then you write it as square root of 4 times square root of 3. Then square root of 4 has been 2 times root of 3 there. So now we are going to work as backward. We are going to do backward steps. We have been given this. Now they want us to write that one there. So coming here on my part A, looking at this, the previous step has been root, and then this has been the square root of the previous number. So the square root to get 3, that number is root of 9. Then times root of 2. Then now, when you look at this step here, now I'm going to multiply them and then put them under one square root. So this one here is going to be root of 9 times 2, and that root of 9 is going to be root of 18. Part B, the number that gave us 4 was square root of 16, then times root of 7. Then here I have root 16 times 7. So this we get root of 112. Part C, the number that gave us the 5 was square root of 25, then times root of 3. Then now here I'm having root 25 times 3, and when I multiply the 2 I get root of 75. Example 3 takes us to the addition and subtraction of surds. Remember we said if we have a root of b plus or minus c root of b, this one here gives you a plus or minus c into brackets root of b. So this is the idea we are going to be using there on all the parts given in that example 3. Part A, we have said you get the coefficients there and then add or subtract them, and then you put the root outside the brackets. So this is 5 plus 7 minus 4 into root of 2 there. So this one here, when I compute those values inside the bracket, I'll be having 8 root of 2. Part B, we are going to do the same. This is going to be 8 minus 5 plus 4 into root of 3. So when I add and subtract what is inside there, I'm going to get 7 root of 3. Part C, I'm having 11 root 7 plus 9 root 7 plus 7 root 7 minus 4 root 7 there. So this is going to be equal to 11 plus 9 plus 7 minus 4 into root of 7. This gives me 23 root of 7. Lastly, we can have surds which are not the same. So don't add them if they are not the same. For example, this is root 5 and then this is root 2. So we cannot add 5 plus 3 there because these roots here are not the same. Then root 5 with root 5, then root 2 with root 2. So 5 root 2, then plus 2 root 2, then now plus 3 root 5 minus 4 root 5. Here I add 5 to 2 and root 2, then plus 3 minus 4 into root 5 there. So when I add here, I get 7 root 2. Then when I subtract here, I get a minus 1 root 5. Example 4, we are still on the addition and subtraction of surds. When you look at part A there, we have 2 terms there. One is root of 20 and another one is root of 5. You can see root of 5 is in the simplest form of a surd, but 20 is not. So what I'm going to do is to first make 20 to be in a simplest form of a surd. I identify 4 times 5 to be the same as 20. Then I substitute there 4 times 5, then plus root of 5. This one here, remember when we went through the simplification. So this is 2 root of 5, then plus root of 5 there. So this one here, this 5 here has an invisible coefficient of 1. The addition of surds coming from the law of surds that we stated, which was the last one, we said you keep the root because that is root of 5 and that is root of 5. Then you add the coefficients. So this is going to be 2 plus 1 into the root of 5, or you factorize out root of 5 there. So when I add, this is going to be 3 root of 5. Now, there is a difference of 3 root 5 and cube root of 5. So I want us to get that difference there. In indices, we talked about the cube roots, and then we say you write the root, the square root, then you put a small 3. So this 3 here is not, the size is not compared to the size of that 3 there. Part B, when you look at the 2 terms there given, also the root of 12 is not in its simplest form. So we are going to first simplify it, and the 12 is the same as 4 times 3 because the 4 is a square number. So this is 4 root of 3 minus root of 4 times 3, and then this one here is 4 root 3, and then this one here, simplifying, root of 4 is 2, and root of 3 there. Keeping the root of 3 and subtracting the coefficients there, this is going to be 4 minus 2 root of 3, and then when I compute that, I'm having 2 root 3 right there. But see, we are going to simplify that. Now we have all numbers of surds there. They are not simplified. So we are going to first simplify all of them. So when you look at 27, the square number which is embedded there is a 9, and 9 goes with a 3. When you look at 48, square number there is 16, and 16 goes with 3. When you look at 75, the square number there is 25, and 25 goes with 3. When you look at 108, the square number there is 36, and 36 goes with 3. So we are going to substitute these ones here for these numbers there under the square roots. So I'll be having something like that. Then now I start simplifying, that is taking the square root of those square numbers there. So this is going to be 3 times square root of 9 is 3, then root of 3 minus square root of 16 is 4, root 3 minus square root of 25 is 5, root of 3, then plus square root of 36 is 6 times root of 3 there. So you can see under the root, I'm only left with a uniform number, that is the 3. Multiplying here, I have 9 root 3 minus 4 root 3, then minus 10 root 3, then plus 6 root 3. So adding and subtracting the coefficients of root 3, here I'm having 9 minus 4 minus 10 plus 6, then into brackets root of 3 there. When I compute everything inside the bracket, I'll be having a 1 times root of 3, which we can simply write as root of 3 there.